My name's Ria. I'm a program manager at Microsoft, and I've been with this project since the beginning. We actually released it about a year ago, and we'll go into some history. So if you went on the website and you saw that Sudhanve was speaking with me, that's actually another PM on my team who hasn't done much yet with Virtual Kubelet, but probably will in the future. But really, we have Ben here, who's been working with me with Virtual Kubelet since the beginning. So I'm going to let him take it away for the first half.
Thank you, Ria. I need to turn my mic off. Thank you for the reminder. Okay. Is that working now? Yeah, we go. Okay, hi, I'm Ben. I'm an engineer at VMware, and I want to take you for the first 15 minutes through, what is Virtual Kubelet? Why does it exist? What are people doing with it? And then Ria's going to focus more on the kind of the use cases, kind of deep dive into how customers are making Virtual Kubelet work for them. It's interesting to note, I think it was this time last year that Virtual Kubelet was announced at KubeCon, and I got very excited by it. Oh, we need to plug this in, don't we? That would help. All right. Yeah, 101 of presenting a thing. Okay, there we go. So I want to talk briefly about why I was excited about it. So I've been working for years on a product in VMware called vSphere Integrated Containers, and we came up with this idea of a virtual container host. And a virtual container host is kind of different to an actual container host. This was back in the Docker days when all we thought about was a single host, in that it's not a VM. It's not like this static thing that you deploy containers into. It's just an abstract concept. It's like this resource limit into which you can deploy any number of containers. But if you don't deploy any containers, you don't consume any resource. And so we came up with this idea of a virtual container host, and the way that it worked is there was just a simple API endpoint that would run in a vSphere cluster. Do I have a pointer here? No, I don't think. Oh, there we go. Yeah. Little API endpoint that would run in a vSphere cluster, and this was what you would connect to with the Docker client. And the virtual container host was just this abstract resource limit, and when you wanted to deploy a container, the vSphere scheduler would take over, and it would figure out which host to put your container on. And then if it wanted to live migrate those containers around, it could do that completely transparently to the client. The client just sees a host, a single thing. But actually, behind the scenes, there's many hosts, and there's all sorts of other interesting and useful things happening. And this is a very useful parallel for the way that Virtual Kubelet is designed to work. So this is just scraped from the Virtual Kubelet README. In the GitHub repo. I highly recommend going and kind of looking at some of the information in there, because there's some good data in there. The idea of Virtual Kubelet, though, is very similar to this idea of the virtual container host that I just referred to, in that it allows us to think about resource, container resource, pod resource in the abstract. A virtual kubelet is not a literal VM. It's not a literal computer that runs containers. It is this concept of an abstract resource constraint into which pods and containers can be deployed in some place. So Virtual Kubelet, in theory, gives you a lot of flexibility in how you not only manifest your containers, but also the resource that your containers use, and indeed as well, like we've seen at ACI, the way that you pay for your containers. So let's delve into this in a little bit more depth. So Kubernetes fundamentally is a node-based scheduling system. That's what it is, and that's what it does. It needs nodes. It will always need nodes, because the node is the fundamental building block of a cluster, obviously. And then the pod is the building block within the node, and containers are little building blocks within the pods. But in a node, we have a lot of conventions that we've come to accept in terms of how nodes work. And here's a list that may be kind of obvious to people, but I think are worth thinking about, in terms of the fact that they don't necessarily all have to be true in order for you to actually just run a container and have a scheduler deploy it. Things like, for example, all the pods run in the same address space, or that the pods share a kernel, or that the node is necessarily a static size, or that a privileged container has to be able to see all of the resources of everything else on the node. I mean, these are all conventions, and some of these things actually, I'm sure, are part of the Kubernetes compliance. But this is how we've come to think of a node. And just because this is how a node is today doesn't mean that we can't be a little bit more flexible in terms of how we think about it to get business value out of Kubernetes. So I'm going to dive a little deeper. This was a diagram that we did when we were looking at Kubelet, kind of early on in the Virtual Kubelet project. We wanted to say to ourselves, okay, well, what functionally does Kubelet do? Like, what is Kubelet? And I actually went through all the code, and the net result of all of that was this one slide, which very succinctly explains what Kubelet is and what it does. Kubelet fundamentally is a node agent. Its job is to, it has two fundamental jobs. One is to manage and configure the node, make sure that it's, all the resources in the node are being correctly apportioned to pods and containers and images and ephemeral storage and all these other things. The second job that it has is pod and container lifecycle management. So the things like starting containers, init containers, liveness and readiness checks, all these other things. Now, the way that Kubelet works is it has two paths, two control paths. One is the asynchronous path, which you see on the left here, which is a polling-based mechanism. And it's actually interesting, because if you go to Kubelet and look for an API, there isn't like a big API in Kubelet. There's not like a start pod API in Kubelet, for example. It doesn't do it quite that way. It has this polling side of the fence, which handles all the things like, basically the lifecycle of any Kubernetes object, and turns that into things like creating and mounting volumes, secrets, configuring the host for DNS, updating a pod, starting a pod, stopping a pod. All of these things are handled by that asynchronous side on the left. On the right-hand side, we have the synchronous path, which is all of the interaction that you might have with a container via kubectl. So if you want to get a shell, for example, into a container, or run a process in it, or get logs from it, that's a synchronous path that goes through this channel on the right-hand side. And you can see some of the high-level function that Kubelet handles down there in the bottom right. And Kubelet also has its own internal control loops. So things like garbage collection, making sure that pods are evicted if it starts getting low on resources. As I mentioned, the liveness and readiness probes. So this is kind of from a very high-level perspective what Kubelet is and what it does. So approaching this from the perspective of virtual Kubelet, you kind of have to ask yourself, well, okay, if we're creating this virtual node that the Kubernetes master is going to interact with, if it's going to look and feel and smell and behave just like a regular node, we need to make sure that we provide both the polling mechanisms that are consistent with Kubelet and the synchronous path that's consistent with Kubelet, so that it will function in the same way. So let's talk in a little bit more depth then about virtual Kubelet and what the point is. Now, I want to just stress, the point of virtual Kubelet is not to replace regular Kubelet. It's not it's not designed to be a ground-up re-architecture or a ground-up refactoring of Kubelet. It's not that at all. It's a Kubernetes client that aims to represent a different kind of resource than just a regular Kubernetes node. So we talked earlier that a virtual Kubelet, the whole point of it is that it allows us to be a little bit more flexible about how we think about nodes and pods. So it allows us to think about them more in the abstract than in the literal way we think about them in a vanilla Kubernetes node. So a node, rather than being this thing with a kubelet in it, this operating system running a kubelet with containerd or whatever else is in there, it's just a bounded amount of resource that can run pods. That is the definition of a virtual kubelet node, quote unquote. And a pod, of course, is a set of containers that are running within a sandbox, but the way that a sandbox is manifested can be something that's quite flexible, because virtual kubelet's not opinionated about that. So when you get into those specifics about what a container is, what a pod is, how you do garbage collection, how you do image management, all these other things, all of that is encapsulated inside of a thing called a provider, which is a pluggable interface in virtual kubelet that allows different instantiations of this virtual node concept to be executed. And I think there's something like 10, is it 10 providers in the virtual, 12? Okay, there's quite a few providers in the virtual kubelet GitHub repo now. There's one for Fargate, there's one for ACI, there's a bunch of them in there. And it's interesting to note that actually, if we go back to this previous slide, like the things that you really need here that are common to every single provider is mostly the stuff in this box on the left-hand side, the polling mechanism, the event handling, and the stuff on the right-hand side that handles the synchronous interaction with containers. That's stuff that every single provider is going to need. So that's the stuff that's in the core, that's in the base. But the base is actually quite small. The common code is a relatively small and simple code base, and much of the complexity is intentionally left up to the provider to deal with. And the interface is exactly what you would expect it to be. It is get pod, stop pod, start pod, right? It's all written in terms of this pod concept that you're then, as a provider, left up to implement and be specific about. So, and it's worth noting that Virtual Kubelet itself can be deployed as a pod, like everything these days. So this whole question of why Virtual Kubelet, I think, is a really, really important question. And Ria's going to delve into that and a lot more when she looks at use cases. But I think it's a really important question. Partly, as I mentioned, because it's important that it's not seen as something that is necessarily there to replace existing kubelet. Maybe it could be named a little bit differently, but it seemed an appropriate name at the time, I'm sure. Ultimately, it's there to give us flexibility of abstraction. It allows us potentially more granularity in terms of the way we're deploying things. Let me give you an example. So I was speaking to Alex Ellis this morning, who's the creator of OpenFAS. And he was saying, well, wouldn't it be really cool if we had like these little IoT nodes, and in each one was a little container engine, and we could just deploy containers or pods into each of these IoT nodes, and then there's going to be this edge controller that just kind of controls all the IoT nodes. Well, wouldn't it be cool if we could add that edge controller to a Kubernetes cluster and get Kubernetes to deploy containers to all these little IoT nodes? I was like, yeah, that would be cool. That is exactly the kind of use case that Virtual Kubelet addresses, right? It's a non-standard node idea in that the edge controller is not a typical Kubernetes node, but the edge controller can handle the scheduling. It can handle, how containers go to which IoT device, and routing and networking and various other things. But you can take a step back from that and then abstract it out and say, regardless of how this is all manifesting, we're still thinking about this as a node, and we're still thinking about pods and containers. So here's just 4 bullet point use cases that I'm going to sort of cover from a high-level perspective before we hand over to Ria. The hybrid use case is one that Microsoft have been demoing a lot with the ACI connector that they have. The hybrid use case is very simply, I have an existing Kubernetes cluster. It may be on-prem, it may be in AKS, it may be, who knows where it is. And I want to have the ability to deploy pods to something that either I can burst into, or that I'm paying for the pod, not for the node, right? Because ACI offers you the ability to pay for containers that are running and pay for pods that are running. The moment you shut them down, you're not paying for them anymore, which is a very, very flexible way to pay for things. Well, this one node can represent that portal into ACI and theoretically infinite resource, right? So it allows your one cluster to have this kind of special magic portal. Sounds like a children's book, doesn't it? Maybe we should write one. For containers and pods to go into ACI and be deployed there. So that's the hybrid use case. An interesting other use case that I haven't actually seen yet, but I think would be worth experimenting with, is one in which you put a virtual kubelet in each availability zone. So you might have a cloud, and you have virtual kubelet that represents pods deployed in one availability zone, and you may have any number of availability zones, and then you add those to a single Kubernetes cluster that can then deploy pods across availability zones. Well, that's kind of cool, because you then keep this notion of affinity and anti-affinity, so you can make sure that your replica set is deployed across availability zones, but with just a single cluster, a single scheduler. So that would be kind of a cool idea. And I mentioned the IoT use case. And then, any use case really where you have a node that really doesn't conform to the way that Kubelet expects things to be, Virtual Kubelet could be a solution for you. So I have a minute before I'm handing over to Ria. I don't want to skip over this, because compatibility challenges is such an important question. It's one that a lot of people immediately want to ask questions about. So I've laid out what I think are the most significant compatibility challenges of Virtual Kubelet. And the first point to make here is that when pods are deployed to a special node, a Virtual Kubelet node, you have to want that to happen. It's not something that's just going to happen automatically. You have to specifically say, okay, this node is special, I'm giving it this taint, and I want particular pods to be deployed to that node. So that's how you might use it. Now, in some of these use cases, a virtual kubelet could represent multiple fault domains, in which case the whole notion of affinity and anti-affinity becomes a difficult one to wrestle with, because it's just a single node, right? So in the case where we have multiple nodes in multiple availability zones, again, you can think about those as fault domains, and you can get that capability back. But it doesn't always map one-to-one as cleanly as a regular node would in a Kubernetes cluster, if that makes sense to people. Now, of course, privileged containers, you can't guarantee that they're going to get access to an ABI and get access to the resources of a node, because there maybe is no node, right? There probably is a node somewhere, but your privileged container is not necessarily going to get you access to that node. Another one is that when you deploy pods in a node, there's quite a bit of configuration that they inherit from that node, either because the node has a volume, like maybe secrets are going to be written to a volume, and you update the secret, and automatically, because the volume is bind-mounted into a container, the container gets to see that updated secret, right? It's inheriting that state from the node. In Virtual Kubelet, again, you can't guarantee that, because there may be no node, or the node may be distributed. So a notion of actually being able to push things to pods rather than pods inheriting a config is something that's been built into Virtual Kubelet. And of course, the provider itself has to either implement a lot of function to deal with all of these things, like image management, volume management. Either you're going to rely on another Kubernetes cluster somewhere, or you're going to have something else that does that for you. But these are the high-level compatibility challenges that we confront with Virtual Kubelet. I think that is that's the last of my slides. So I'm going to hand over to Ria. Thank you. And we're going to have time for questions at the end. So
yeah. We're going to have a lot of time for questions. OK, so I'm going to take the perspective of, first of all, a provider, but then also a customer. So within Azure, we decided that we needed Virtual Kubelet for a couple of reasons. And I actually want to skip forward to this slide and then go backwards, because I want to go through the history first. So it was about a year ago when we came together, and we had this project called the ACI Connector. It was something that Brendan had just come up with. He believed that pods and nodes were too tightly bound in Kubernetes, but instead of trying to go in and change Kubernetes, we decided to work around that problem and create the ACI Connector. So it was actually just a bunch of TypeScript. If you want that old code for some reason, let me know. But it only worked for ACI. It only worked for Azure. And ACI is Azure Container Instances. So on the fly, we can spin out just containers to customers on demand. So it's build per second. You can choose the amount of CPU you want, the amount of memory, but you don't have to manage it. So there's no node underneath. You don't have to deal with any of that. You just give it an image, the amount of resources you want, and you're good to go. And you can get a public IP, you can get a private IP. It's really whatever you want. So that's why the ACI connector was born, because we started to think about, what if you could burst from Kubernetes to this unbounded resource, to ACI? So it's a completely different service. It doesn't lie in your cluster. You don't manage any of those resources, but if you need it, it's there for you. So that's when it was born. And then we built Virtual Kubelet, because we realized that this was a problem, and this was something that other providers could build into. So that's why we made it pluggable. We made the Virtual Kubelet project, and we released it as a community project this time last year. So it's been a year, and I'm really excited that literally a couple weeks ago, we were, now we're in the CNCF. So it's really great, because we've been working for a really long time on this. It's been kind of a struggle to figure out where the right home was. We tried to go into Kubernetes, and we're like, maybe this isn't the right place. We can live without Kubernetes. We have no dependencies on the kubelet. It's just an abstraction above it. So some challenges of creating a provider. As Ben talked about before, a lot of those decisions are on the provider to create. So within ACI, within the Azure provider, we had to go back and figure out how networking worked. How do we spin up a kube proxy? So we actually do it as a side container that customers don't see. So you don't see any of that complexity. We just say, what subnet do you want? What VNet do you want? And we give that to you. You don't have to configure anything. And then service creation was also difficult. How can you get a bunch of these pods to be backed by one service? Also, what should a max node resource be? This is something that I've thought about a lot. I mean, we have it exposed in Kubernetes, but it's not important to you as a customer, but it does become important if you're starting to realize that your service is running out of resources. So ACI itself will tell you, hey, we don't have enough resources for you to spin out, but how do we expose that in Kubernetes? That's something we're still working on. What version is Virtual Kubelet? This is something we just talked about in our last meeting. Do we go by the Kubernetes version? Do we start to track Virtual Kubelet with Kubernetes versions? That doesn't make sense, really, because we're not dependent on the kubelet. So we don't actually care about what Kubernetes version you're running. But we do have a version of Virtual Kubelet, which has different features and different capabilities. So we do want to expose it. So maybe we rewrite the kubelet version, which is something you might see in Azure in the future. And then how do we enable customers to monitor their pods? So a lot of the time, monitoring comes out as a daemon set. It's kind of difficult because all of your logs and your monitoring data is held in this other service and not on your nodes that are in your cluster. So we basically have to create those pipelines for you to be able to expose all of that monitoring data. So as a customer, these are kind of the things that you'll start to see, the decisions that I think of when we're looking into the ACI provider. So yeah. So some use cases. One that Ben also went through was the IoT Edge use case. We do have an IoT Edge provider, and basically you can represent a node as a device or multiple devices, and anytime you spin out a pod to it, you can update the deployment and maybe change the color of a light, for example. That's kind of an interesting use case. You can also represent maybe meters or IoT Edge devices around the world or whatever you need to read, and just use Kubernetes as a common API to deploy things to it. And then the virtual node architecture in AKS. This is something that we use deeply in Azure. It's a use case that we talk about all the time. But basically, you have your normal Kubernetes cluster. You have your normal nodes in your cluster. And then you have this thing called a virtual node. So it looks like a node, but there's no resources that are backed by it. It's literally just a string. When you say kubectl get nodes, it's just a string, and it kind of looks like a node to you. Anytime you spin out a pod to that node, you're actually spinning it out into ACI. And ACI has a lot of different configurations. So you can have Linux or Windows, you can have different regions, and then Virtual Kubelet has a lot of different providers. So if you start to think of that, you can have Kubernetes as your common control plane, but you can start to spin out to different clouds if you want. It's not a use case we support, but you could. You could have a Virtual Kubelet that's spun out to different regions within the same cluster and manage it from one place. You could even have a Virtual Kubelet representing a completely different cluster, like Service Fabric or something else. These are all things that have been enabled by Virtual Kubelet. Maybe there are things that you want to experiment with or try out. They might not be customer or enterprise level use cases, but I think that's okay. I think a lot of these use cases will start to spring up. But yeah, so we use ACI as something in Azure, in AKS, and we basically use it as this unbounded resource where you don't have to manage the nodes. And that's really important for customers. They can also scale out on demand. So we're really thinking about how you auto-scale, how you scale quickly without having to scale up nodes, because that can take quite a long time. Or 5 minutes, but with ACI, you can spin out a bunch of containers in about a minute, which is really important for customers. But how do you do that? So the first way you do that is by adding a toleration to your virtual node spec. So this allows you to be scheduled out to Virtual Kubelet. If you didn't have this, you wouldn't be allowed to because we have a taint on the node itself. So you just have to keep this in mind. You can also add a mutating webhook into your cluster, and basically anytime you spin out a pod in that namespace, in the provided namespace, you can get this added to your pod spec so you don't have to think about it, which is nice. So the key right here is Azure, but you can have any provider in there. And then you can add affinities to burst out from ACI to AKS. So, and this can be used also in any kind of cluster. But if you have this node affinity, basically what we're saying is prefer the nodes in the cluster, fill those out, and then burst out to ACI. So you want to actually fill out the nodes that are in your cluster before you burst out, because it's just going to save you money if you already have those nodes. But you want to have that extra burst capabilities if you need it. So one example is a Black Friday example. And we also have like a demo that you guys can try out in our Azure Samples repo. But basically, if you have a lot of load coming in and you haven't pre-provisioned your nodes for a couple good reasons. One, you don't want to spend a lot of money. Two, maybe you're not really sure when the load's going to come in. Maybe it's going to be midnight. Maybe it's going to be 3 a.m. But the biggest thing is you don't want to provision all those nodes and have to manage them. So you could have Virtual Kubelet installed in your cluster, or virtual node, and then automatically you can be scaled out into ACI without thinking about it. So with this node affinity, you can do that. All right, so now I'm going to show you how it works. So that was kind of like the use cases and the higher level ways that you can use Virtual Kubelet as a customer. But what do you actually see when you look at your cluster? It's really simple, but I'm going to show it to you. Oh, I exited my desktop. Oh no, that was wrong. Okay, and show. Cool. So I'm just going to head over to my command line, and I'm going to go back to mirroring my display, or I'll just move this over, and it's going to be weird. Hold up. Okay. There it is. All right, I'm going to type and look at this screen. It's going to be fun. Do you mind holding this? I think I can talk loud enough. Okay, so I'm going to go ahead and say my command line's on the bottom. And I'm going to kubectl get nodes. It's the first thing you do when you get a cluster. So I'm going to do that. And once this comes back to me, the Wi-Fi is unbelievably slow here. And I've been trying this all morning, but it's the easiest demo you can do. So we're going to wait for like 3 minutes. While we wait, does anyone have a question?
Yes, there's one over there.
How do you connect bursted out containers to your on-prem containers or your regular Kubernetes containers?
So you're asking how to burst out to on-prem?
No, how they connect.
How they connect?
Are you talking about like?
Repeat the question.
Yes, I'll repeat the questions.
Oh, yeah.
So the question was, how do you connect containers in your on-prem cluster with containers in your ACI cluster?
On-prem containers to your ASIC. I thought you were going to take it.
No, I wasn't. You're the ACI expert.
Repeat it one more time for me.
You weren't even listening.
We're done with the question.
So you have an on-prem cluster, actually, or you may have a cluster in AKS, because actually Microsoft have a solution for this. If your cluster is in AKS and your virtual node is in ACI, they have this really cool networking feature where they can talk to each other and they get IP addresses in an appropriate subnet so that they can all see each other and talk to each other. With the on-prem solution, Ria, you're going to have to take that or Jeremy, because I don't have an answer for that.
Like, so you
have
have
an on-prem cluster.
You have an on-prem cluster, and you're trying to spin out to ACI.
Yeah.
Basically.
How do the containers connect to each other?
How do they connect to each other? You're actually pinging Azure. So the way we have it is you can install Virtual Kubelet onto an on-prem cluster, the virtual node that we have in Azure. You'll have to do it manually, and you'll have to, in your pod spec, say, hey, I'm part of Azure. This is my subscription. This is my service principal. These are all the details, and that's how we know we're allowed to spin out to Azure. So that's what you have to do. It's the same code, actually. So there's nothing different. It's just you have to tell the cluster. Like, the cluster just sees the node, so it doesn't have to do anything. The code itself is what's saying we need to connect up to the ACI APIs.
But I still don't get how your on-prem containers would talk.
Do you have, yeah, as long as you have internet, you would be good. Is it?
Okay, so how do these containers come up with a public IP?
Yeah. So the way that you would do it, you would need to have public IPs in it. But we don't have a solution with VNets yet. We need to get VNet peering, for example, or other ways to connect to your on-prem VNet. So that technically wouldn't work with the networking. But talk to me after, and we can talk about like what we need to do to enable that. Anything else?
Is your cluster come up?
Yeah, it came up. It's great. Okay, so that's my cluster. That's what a virtual node looks like, and this is what my AKS cluster looks like. And I actually just went through the portal and I said, create a virtual node, enabled it. You can also use a Helm chart. You can use this thing called the ACI connector, but it's really whatever you want to do. It shows up like that. And now I'm going to go ahead and create a pod. So this is also going to take a couple minutes, so since it took so long to get through. Okay.
What resource limits does the virtual node ACI connector report? Can that change?
It can change. It reports like 3 terabytes today. Yeah, so it's like 3 terabytes. It's some ridiculous amount of, like, we just have a huge number for it. We are thinking of, we could change it to what the limits are in ACI. So ACI itself has limits for per customer. Today it's 100 container instances. Did it come up? Already exist. Oh, well, we can just kubectl get nodes. I guess I created it. That's good. We'll get pods now. But yeah, so that can definitely change, and that's something that we're thinking about.
So in your example, you're extending AKS, right, with the virtual kubelet,
Mm-hmm.
but the nodes are still running, and in one of the slides you talked about pay-as-you-go. So in this case, you're not necessarily purely serverless, right? You're still paying for the AKS nodes which are running.
You are, yeah.
So what exact benefit do I have with this respect to this example?
You want to just repeat a summary of the question?
Yeah, okay. So he's asking about, we still have a node in our cluster. What is the benefit since we still have the node with Virtual Kubelet in this scenario? Because you're still paying for that node. That's completely true. Your benefit is really you being able to burst out quickly without having to scale up nodes, because that can be difficult. The other thing is we are working towards a solution where you wouldn't have nodes in your cluster at all, which would be really cool. So now you can have actually a cluster with just virtual kubelets or virtual nodes, and you can spin out to ACI or have nothing running if you don't want to have anything running. So that's something that we're working on within ACAS. It's back. Okay, so it's running. So this is actually on ACI, but what I'm going to do is wide so you can see what's happening. It's in a private VNet. We have all of that working. If you're within an Azure networking. Oh, that should just work. Yeah. It's shorthand. Yeah, I know. It's crazy. That will work. This is like like I couldn't do a real demo up here because it's so slow. But we have a bunch of samples and things that you can pull from. But yeah. Questions?
One of the assumptions we do one of the things we need for bursty loads is we need to cache the images because our images tend to be quite large.
Okay. I guess so. Yep.
Can you make any of those assumptions with the ACI connection?
Yeah, so today, I'm speaking from a provider perspective, this would be the same for Fargate or anything else. We do not cache images in Virtual Kubelet or anything like that, so it's really up to the provider to allow that the ability. We don't have an ACI. We do cache common sub-images or base images. So we do that. But that is a common question that we get. Can we cache our entire image? And we're like, how would we do that? So you can see here that it's running on Virtual Node Linux. So it's running on ACI. It's in a private VNet, which was a really common ask feature. We just enabled it. You could also create a service in the same kind of way. So that's how you would use it and get started as a customer.
So just to clarify on that point, from an ACI standpoint, my understanding, I'm not an expert in this, and maybe Brian or someone can correct me, my understanding is that it's backed by Kubernetes in the back end, right? Mm-hmm. So ultimately, when you deploy a container, it's going to end up on a node somewhere. That node will have a cached image on it, but there's no guarantee any time you deploy it, it's going to end up on the same node, and that's the challenge that you have. Because at the moment, there's no primitive in Kubernetes that says, make this image available everywhere because I don't want any latency. Mm-hmm. I mean, you could deploy a replica set or a daemon set. Actually, daemon set would be the appropriate way to make sure that image gets cached everywhere. But again, you're limited with this because the daemon set doesn't work with this abstraction. That's a good observation.
Have you thought about a infrequently connected virtual node, like say an IoT device that's maybe over a satellite internet connection? How would that work? And have you got any specific support for that kind of?
Not currently, no. I mean, I think that the nice thing about the virtual node is that you could create an asynchronous relationship between, because in a regular node, kubelet and the things it controls is all synchronous. With Virtual Kubelet, because you're not tied to that paradigm, you could make it so that you were queuing things up inside the virtual node. When you made the connection, you could get the status back and you could launch new things. I mean, maybe that would be the right way to do that.
That's really interesting, though. We should work on it. Someone was making a pizza provider yesterday, but I think this is probably way cooler.
Do you have any challenges trying to keep up with the kubelet interface changing? Or is it not pretty stable?
The funny thing about the kubelet interface is there really isn't much of a kubelet interface. It's actually the API server interface that matters because, as you saw in that second slide, most of what kubelet does, it does through polling behavior. And the only interface, quote-unquote, external interface that it has is the synchronous interface for exec and attach and logs, and that's relatively stable. So it's actually more a question of, as things get added to the API server, how stable is the API server API? And Kubernetes is doing a great job of keeping that stable.
Yeah.
The use case we've got for this is running Docker and Docker and So we were looking at other options for that, so to virtualize that. And so like this seems like a good solution possibly.
Mm-hmm.
So like, but caching is like a big piece that would be nice. And, you know, those build images, having those cached. But I guess, could you speak to that at all, as like as a build, or like as a, that could run anywhere from like 10 to 100 build pods.
Do you want to use ACI, or are you making your own provider for this? ACI will not work. So
You can't.
you cannot do Docker and Docker with ACI. We have tried. The ACR team, the Azure Container Registry team, has come to us multiple times asking, and multiple times we said no. It's just not what we're going to add as functionality in ACI. But if you were to build your own provider, you could do it.
So for ACI, does that come down to the hypervisor and the virtualization you have in the machine?
Yeah, I mean, one observation I make about that is, you know, the virtual container host concept I talked about earlier, a very popular use case for that was connecting to a CI/CD pipeline, because anything that you do that is transactional, right, that runs for a period of time, takes input, gives you output, and you may have bursty periods and you may have completely quiet periods, you don't want to be reserving resource for that and paying for resource for that.
Plus the isolation.
Right, exactly. So I think there are good solutions to this. There will be good solutions to this. ACI may not be it, but there are good solutions out there. If you're a VMware customer, come talk to me, because I might have a solution for you.
Yeah. All right. Okay. I think we're going to end right here, but feel free to come up, talk to us after. There's also a deep dive session by Brian and Jeremy on Thursday, so check that out if you want to learn more. But thank you so much.
Yeah, thank you.